Assistant Professor in the Department of Psychology. Welcome to a unit on memory where we'll explore the fascinating nature of memory as a cognitive storage system. Think of memory as a bank where we store our experiences and knowledge. Just like how you would withdraw money from a bank, we can recall or retrieve information from our memory when it is needed. The very first experimental study on memory and forgetting was conducted by a German psychologist, Hermann Ebbinghaus, who pioneered scientific research in this area. He used himself and his children as subjects for his experiment. He introduced the concept of nonsense syllables like T, E, G and P, X, T, which are still utilized in memory research today. Now, let's explore the historical perspectives on memory. Both Aristotle and Plato compared memory to a block of wax, suggesting that its size and hardness can vary among individuals. This analogy illustrates that remembering is like stamping an impression onto the wax. As long as that impression remains intact, the memory is preserved. If the wax is either too soft or damaged, the impression may either fade or disappear. This symbolizes how memories can be fragile. This whole metaphor highlights the importance of conditions under which your memory is formed and retained. Interesting. Now, let's also discuss a fascinating process of memory which consists of three key stages. It starts with encoding, storage, and retrieval. Encoding is very crucial because it involves transforming information into a format that our brain can understand and retain. Think of it like typing in a computer keyboard. When you strike the keys, your actions are converted into binary codes that the computer processes. Similarly, when we encounter new information, our brains encode it into encoded formats. This could involve associate new concepts with existing knowledge or create mental images to help us remember. The very next step is storage. Once information is encoded, it needs to be stored for future use. Just as personal computers save data on hard disk for later uses, our memories are stored in various forms within our brains. This storage can be either temporary or long-term depending on how we process the information. For example, short-term memory holds information for a very brief period of time, whereas long-term information retains it for extended duration. For example, your address. Finally, we arrive at retrieval. This is a process of accessing and bringing stored memories back into a conscious awareness. When you press certain keys on a keyboard, you provide cues that help the computer retrieve specific information. For example, if I ask you, what is your address? You can immediately recall it. The same way, we use cues such as contextual hints or sensory triggers to access our stored memories. These cues can significantly enhance our ability to recall information effectively. So using all these three stages of coding such as storage, retrieval and encoding, we provide valuable insight into how memory functions and highlights the complexity of a cognitive process. As we continue this unit, we will explore each stage in more detail and discuss strategies which will help you to improve memory retention and recall. We will explore two influential views on memory that have shaped our understanding of how we process and retain information. The most two important things are the information processing model and the model memory. This model presents memory as a structured system that operates through distinct stages: sensory memory, short-term memory, and long-term memory. Each of the stage represents a different function in the processing of information, which emphasizes a linear flow where information is first captured by your sensory memory, then it's encoded into your short-term memory for immediate use, and finally translated to your long-term memory for longer retention. This model likens the brain to your computer, illustrating how input is processed sequentially and stored for future retrieval. On the other hand, we have the levels of processing model, which shifts the focus from structured stages to the depth of cognitive process involved in memory formation. This is originally proposed by Craig and Lockhart. This model persists the quality of encoding, whether shallow or deep, significantly affect how well we retain information. The deeper the processing, the deeper the meaningful connections, while we engage with material on a more profound level, which leads to recall better, and mere repetition of surface level engagement doesn't work. Both the models aim to explain how memory works and highlights which is importance in learning and cognition. They provide framework for understanding the cognitive process which is involved in transforming initial perceptions into long-term memories. By examining these two perspectives, we can give a comprehensive understanding of memory's complexities and apply this knowledge to enhance our learning strategies. Over the past 3 decades, memory research has been profoundly influenced by the cognitive revolution in psychology. This movement shifted the focus from behavioral approaches to understanding the mind as an information processor. Much like how a computer works, the perspective emphasizes that a cognitive process such as perception, attention, and memory are essential for understanding how we learn and interact with the world. One of the key contributions to this field is Atkinson-Shiffen model of memory, which outlines how we process information through 3 successive stages. As we discussed in the last slide, the first stage is sensory memory, where information is briefly held in its raw form. This stage allows us to capture fleeting sensory experiences such as sight and sound for a very short duration. Whereas we focus on studying about the short-term memory, in this stage, information that we pay attention to is actively processed and temporarily stored for immediate use. Short-term memory has a limited capacity, often described by George Miller, which is a magic number. We can hold approximately up to 20 or 30 seconds of items, which is 7 plus or minus 2. Finally, we have the long-term memory, which serves as a more permanent storage system for information. This long-term memory can retain vast amount of information over extended periods, sometimes even a lifetime. This model highlights how information transitions from one stage to another, emphasizing the importance of encoding and retrieval process. While we understand these 3 stages, sensory memory, short-term memory, and long-term memory, we gain valuable insights into how our minds process and retain information, which will further enrich our comprehension of memory in psychology. Let's start with the sensory memory, which is where information enters the nervous system through our senses like sight and sound. Sensory memory holds exact replicas of stimuli for a very brief period, less than 1 second, allowing us to retain an exact copy of what we see or hear momentarily. For example, iconic memory lasts about half a second, while echoic memory can last up to 2 seconds. Information then transitions to short-term memory, which can hold amounts of information for about 20 to 30 seconds. Selective attention plays a very crucial role in determining which information moves from sensory memory to short-term memory, where it can be enhanced through techniques like chunking, as we discussed before, which was initially proposed by George Miller, which is 7 plus or minus 2. Now, let's look at the components of working memory, which plays a very crucial role in our ability to hold and manipulate information in real life. Working memory is also called as the working bench memory, which is not just a simple storage system. It consists of several interconnected components that work together to manage different types of information. For example, if you go back to your home today, you will use your table to read. You will use your table to store books. So the book that is on your table is workbench memory. First, we have the central executive. This component acts as a control system of working memory, directing attention and governing responses. It is responsible coordinating the activity of other components and deciding which information should focus and process further. The central executive plays a critical role in managing cognitive resources effectively, ensuring that we can prioritize tasks and switch between different types of information as needed. The next is phonological loop, which specifically maintains verbal information through rehearsal. This component allows us to hold on to spoken word and sound, making it essential for tasks like remembering phone numbers or following verbal instruction. The phonological loop helps us keep verbal information active in our minds through repetition. Then we have the visuospatial sketchpad, which is responsible for holding visual or spatial information. This component particularly enables us to visualize objects, navigate spaces, and remember visual details such as the layout of the room or the appearance of a person. Lastly, there is the episodic buffer. This component integrates information from different parts of the working memory, combining visual, spatial, and verbal information so that it makes sense to us. The episodic buffer serves as a bridge between working memory and long-term memory, allowing us to coherent representations of our experience. Together, these components work in harmony to facilitate complex cognitive tasks. Understanding how these elements functions helps us appreciate the intricacies of working memory and its vital role in our everyday thinking process. Finally, let's discuss the concepts of rehearsal and long-term memory, which is also called as the LTM. Rehearsal is a critical process that involves repeating information that has entered the short-term memory to facilitate its transfer into long-term memory. The technique can take various forms such as maintenance rehearsal, where we simply repeat information to keep it active in our mind, or elaborate rehearsal, where we make meaningful connections to the existing knowledge. By actively engaging with this material through rehearsal, we enhance our chances of encoding it into long-term memory. One of the futures of long-term memory is to hold a long capacity. Memory is nearly limitless storage capacity, unlike the short-term memory, which can only hold a small amount of information for a very brief period. Long-term memory can retain vast amounts of information for extended duration, sometimes even a lifetime. In fact, more the knowledge you acquire, the easier it becomes to add new information to your memory. This is often referred to as the knowledge base effect, where prior knowledge facilitates the learning of new concepts. This also serves as a lasting storehouse for meaningful information, which plays a vital role in our ability to retain and grow intellectually. It allows us to recall past experiences, apply learned skills to new situations, also build upon our existing knowledge. The capacity for long-term memory is essentially not only for academic success, but also for personal development and everyday functioning. In summary, understanding the role of rehearsal in transferring information from short-term to long-term helps us appreciate how we learn and retain knowledge over time. As we continue our exploration of memory, we will examine strategies to enhance both rehearsal techniques and the effectiveness of longer memory in the upcoming units. Thank you for your attention. A few reflective questions which I want you to dive deeper into the concepts for better learning.